Today I am going to be talking about Overcoat for Maya, a project by Nathan Zeichner and Shijin Liu for CIS 660. Overcoat for Maya is a non-photorealistic rendering system that attempts to capture a matte painting-like style. Unlike other NPR methods, Overcoat approaches this problem by embedding strokes into a 3D scene. This allows an artist to create 3D matte paintings, which can be used for 3D concept art or complex illustrations for conventional or digital books. The major benefit to this system is that it utilizes the traditional skills that an artist has. One of the main features of Overcoat is the ability to embed a 2D stroke into 3D space. This is accomplished through a click and drag interface in the 3D camera view. As the artist draws, a dotted line appears to show where the stroke is being created. The artist is able to use 3 different tools to create their strokes: the hair, feather, and level set tools. Each one creates a different type of stroke in 3D space. Another main feature of Overcoat is the ability to render 3D strokes back into 2D images. After the artist finishes drawing, they can choose different sizes and names from the Maya rendering settings. Then they can either click the regular render button to obtain a rendered image from the current camera view, or they can click the batch rendering button to obtain a series of rendered images from a panoramic camera. This plugin is based on the paper Overcoat, an implicit canvas for 3D painting. In this paper, the authors present their system for embedding strokes into their own 3D software. This project re-implements their features in Maya. Overcoat for Maya has the same 3 tools for creating 3D strokes as Overcoat. Each of these tools works by projecting a 2D screen space stroke as a 3D spline onto a proxy mesh. The initial click must intersect the mesh's surface in order to know where to project. The hair tool projects a spline based on the first click polygon's normal. The feather tool works similarly, but uses the first click polygon's tangent. The level set tool projects a spline based on the level set defined by the surface of the mesh. The user can adjust which level they want to paint on to create a layering effect. Overcoat for Maya has the same non-photorealistic renderer as Overcoat. The non-photorealistic renderer first sorts each stroke according to their depth order. Then each stroke is projected from 3D space onto a 2D image plane through the camera view. Finally, each stroke is painted with their unique thickness, transparency, color, and brush type in 2D space. The stroke embedding tools were written in C++ using the MPX context and the MPX context command classes from the Maya API. These tools are completely integrated into Maya and act exactly the same as any other tool. The tool handles mouse input from any 3D viewer in Maya and set up the splines as needed for rendering. The tools also call OpenGL drawing calls in order to give the artist better feedback on how the spline is being drawn. The user can edit the tool's attributes like any other tool in Maya by double-clicking and opening the Tool Properties window. The user can alter the parameters of the tool to determine how each spline will be rendered. The non-photorealistic rendering tool was mainly implemented in Maya API using information from the MFN NURBS curve, MFN camera, and mCommon render settings data classes. The rendering tool also uses EasyBMP to extract pixels from the sample images for brush implementation. The rendering tool also renames each Overcoat node to get rid of all deleted Overcoat nodes. Then it obtains parameters that the user previously set for each Overcoat node and applies these parameters to each stroke in the rendering process. This video shows the user opening up the hair tool and using it to draw small strokes along the normals of a proxy mesh. Here we have the feather tool, which allows the artist to create wisping strokes that follow the form of the mesh but allow the artist to move off the surface of the proxy mesh. Lastly, here is the level set tool, which shows the user painting on the surface of the mesh. The user can adjust their level set in the properties window and change the depth on which they're painting. This video shows all 28 brushes rendered through a panoramic camera using the batch rendering system. The changes in the depth order can be seen in this video as the camera changes position and direction. Here is an example of a proxy mesh that can be used in our system. Here's what the resulting painted version looks like in our rendering system.